And now we are recording. Perfect. Okay, can everyone hear me? Excellent. So how, let me share my screen. Share. Okay. Perfect. Okay. Hop over here. So first, before we start, so my goals for this week are to go ahead and lecture on the standard built-in objects on JavaScript. So that would be the date object, that would be the math object, and talk a little bit about serialization using the Json object. And then I'd also like to pivot to the document object, which will allow us to start interfacing with the browser's view, and also cover event handling, event listeners, and just events inside of the browser. So by the time we're done this week, we should have essentially completed everything we need to for HTML, for CSS, for styling with Bootstrap, comprehensive deep delve into JavaScript, and all of its interesting parts of the API that we really care about for the browser, so that we can like update our HTML content, so that we can build sophisticated software that uses either an object-oriented paradigm or a functional paradigm or a procedural paradigm, depending on what fits best for the application that we're trying to scaffold out, and how to best utilize all the resources the browser provides to us. And then once we're done with that, next week we should be starting with asynchronous JavaScript programming, so that we can start using our browser to start making REST calls as a REST client to start making calls to servers. And once we have an understanding of how to start using HTTP to send requests out, we will flip to the other side and start looking at web servers. So before we do that, we'll probably take a delve at a front-end library that's built in JavaScript that's called React. And so for React, we'll have to install Node before we build web servers to be able to compile our JSX. But that's a little bit in the future, so we don't really have to worry about that this week at least. Okay, so before I start, though, I kind of want to get impressions on how people are feeling about JavaScript as a programming language based off their experience with the lab. So how many people have started the lab thus far, and what are your impressions in terms of your comfort level with JavaScript? Okay, let's see here. Perfect. Yeah, and so for those of you who have not started, pay special note when I do my variable declarations. If at any time I declare a instance variable with a hashtag in front, and I omit that hashtag in some later step when I try to dereference, insert that, or it will cause you some issues. Oh, that brings up another good point that I do want to distinguish between Java and JavaScript before I start today's lecture, is that, and maybe I mentioned this before, but if I hadn't, I definitely want to highlight it now. Probably one of your early experiences going through Java was learning how to do like Hello World, learning how to generate all your Java source code files. But as you might recall, you would then have to compile all of your source code into object code or bytecode before it could go ahead and execute, before you could actually send it to the JavaScript virtual machine. And so when you go to compile, one of the things that you probably encountered was the verbose amount of error reporting and exception reporting that Java does for you. So one of the nice things, and that's one reason why Java is so heavily used for enterprise level software, is because it logs a lot of it's very verbose in its reporting. So JavaScript can be a little nuanced differently in the regard that it will silently fail. And so what that means is that if you have code that doesn't resolve either because of exceptional behavior, or maybe you could even consider it something that could be error-like, it will just ignore that and skip down to the next statement without necessarily reporting that there was a erroneous behavior. And the reason why that decision, and this was an intelligent decision by the designers. This was something they decided was the way to go. And the reason why that is that the browser is such a ubiquitous platform, and it's so easy for anyone to go ahead and generate JavaScript code and make it publicly available. And web applications are so pervasive in the idea that all you have to do is go to a URL, and if that HTML document at that URL embeds JavaScript into there, then that JavaScript will run inside of the browser. And so for that reason, you can have one browser that opens up several different tabs. There was a conscious decision that you should not crash the browser or report to the end user every and all exceptions or errors that occur if there was bad JavaScript implemented. And so that's the reason for the silent failures. The decision was that if you do open a page that might have been poorly implemented, just to try to ignore what you can and run what you can. Ignore what doesn't work and run what you can, and let the user be none the wiser with that. So that works fine in practice from an end user's perspective, because that means if the JavaScript isn't working, you just have functionality that doesn't work. And again, this is probably coming from the concept that JavaScript initially emerged as a front-end language. It was designed to make your web experiences more interactive and more dynamic, to be able to move elements, readjust elements, to be able to sort the content in tables based off of a number of different parameters, or anything else that you'd want to do to have interactivity in the front end. But JavaScript has very much grown beyond that original original use case, and so often is the case that you do want to evaluate your code base. So they do make testing tools, and we'll try to find time to cover some of the testing tools for JavaScript. But for right now, one of the most powerful things you can do when you're debugging is to constantly put console.logs in to your software so that you can evaluate the state and use the dev tools as much as possible. Okay, that was just a small bit of a tangent, but I did want to distinguish between Java and JavaScript in its error reporting, where one is very verbose and the other is very loosey-goosey with it. Okay, let's see here. Yeah, that's how I usually like to describe what JavaScript is. It's at least modern JavaScript is very much, to me, a blend of Python and Java. So I can take my approach to designing software in a very Java-like way and implement JavaScript in that same kind of characteristic. Or I can take software. Now, I could do the same thing in Python as well, since it supports classes and whatnot. But I could do the same metaphors, and the availabilities that I have in Python are also there for JavaScript. So yeah, if you've ever done Python, a lot of the things we do in JavaScript in terms of being able to declare dictionaries or our arrays, or have a lot of the built-in functions for those, are very, very similar. So it would be very easy to pivot from something like JavaScript to Python, or something from Python to JavaScript. And hopefully with the way that we're presenting the material, it should be pretty easy to go between Java to JavaScript. So for those of you who have not done Python and you start to feel comfortable with JavaScript, I would implore you to next check out Python, as that is a great and wonderful language with all sorts of great use cases. In particular, if you're interested in either DevOps, or if you're interested in cybersecurity, or if you're interested in anything related to scientific computing, including data sciences, or artificial intelligence or pattern recognition or computer vision or things like that. Python's a great, powerful language for those. And I guess before I move on to showing some of the built-in, with that said, is there any courses that cover Python? I know that they just recently introduced, I think, machine learning in Python or scientific computing in Python, but is that in any of the core classes? Do you do Python, for instance, in system programming concepts? Oh, okay. Okay, well, perfect. So if you don't necessarily, or if you're not necessarily required to do Python, then at least JavaScript would be a good stepping stone to get you onto the next of the hopscotch of languages that are worth learning. Okay, so the first thing I'm going to do is I have slides prepared for my, nope. Okay, I have slides prepared for the DOM, but before I move to the DOM, I just want to go through some of the built-in objects, and this shouldn't take too long because a lot of this should be similar to what we do in Python. Oh Lord, you have the Camel Bible. You know, Perl is like the Swiss Army of programming languages. There's 100 different ways to do the same thing. Okay, let's see here. Where did my okay, let me get a new window, and okay. Okay, so I'm going to open up a empty console just to play around with. Oh, one other thing that I don't know if I mentioned. So when I did the DevTools walkthrough and I showed how to access the console and whatnot, did I show all the different ways to get to do the what the about? So we do about : blank. Did I ever describe what about : blank is doing? Did I talk about that when I did DevTools? So in addition to being able to look at this, okay, so in addition to being able to look at the source code and my DevTools, which allows me to access the JavaScript console, inspect elements and whatnot, the URL bar itself inside of browsers have a special keyword you can type in. So this address bar is used to be able to open up your documents. And so there's an internal set of documents on a browser, and then there's external documents that can be imported into a browser. Now, you can import external documents into a browser either using the file protocol. And so that's like if you just double click on a local HTML file, it'll default use the file protocol. Or if you open up a file pathway into the URL address, it'll also use file protocol, which, as we talked about earlier, is it's got limited or restricted access to the browser's capabilities. Your full capabilities with the browser will not be open unless you use the HTTP protocol, which we will talk about later, but I'll give the name of that so it's not so elusive. That stands for the Hypertext Transfer Protocol. So essentially it's just the set of rules by which we transmit hypertext documents from one location to another, and that's what HTML files are, hypertext markup language documents. And again, that's the original purpose of a browser, is to be able to act as a web client for the purposes of parsing and viewing HTML documents. So in addition to being able to use the HTTP protocol using the URL bar and using the file protocol, there's also the about protocol. And the about protocol accesses all the internal attributes of your Chrome. So about : blank gives you a blank page that has no HTML code in there. But why don't we just do about so that we could see what that looks like. So if you do about, it'll give you the list of all the other things you can do internally for your browser. And there's lots of cool things you can look in here. I don't want to spend too much time. I'm just illustrating that this is another aspect of your browser that you can go ahead and investigate and see what's happening in here. And so you could, like, for instance, see what the GPU available to your browser is. If you're going to do some WebGL stuff, you can see what's happening. You can check your flags, your apps. So if I wanted to check my apps, for instance, in here, I could probably just do about:\apps without having to go to the hyperlink, and it'll bring me right to the app. So this is a way to navigate all the internal structures of the browser that's available. And again, if you want to see what's available there, you can always just do about:\. Okay, so I'm going to go back to my about:\blank, which is by default a blank page. So if I go to my dev console here and inspect the elements, you'll see it's just an empty HTML. It gives me, and the only reason why I like that is it gives me this nice empty terminal from the browser, so I can go ahead and have interactive code. So I just feel if we're going to learn how to do front-end development, we should know how to do almost everything we need to using the browser as well. Feel very comfortable with the browser. Okay, so inside of JavaScript, just like with Java, we have a standard library, and that standard library gives us lots of cool availabilities to things like the math class. We have those same options here inside of JavaScript. So why don't we take a quick look at some of the things we can do with the math class. So to use a math class, I would go to MDN. So moving forward, this is the way you should always look up anything you have a question related to JavaScript. And if I type in math dot, and okay, so first of all, there's lots of properties, constant properties. So if I need the calculation of E, I can just access that. Or if I need my value of pi, I also have access to that. Very similar to with Java. Okay, let's see. If I have more complex computations I need to do, I have all these different methods. Now, all the methods inside the math class, just as they are in Java, are static methods. So I would invoke these methods using the class name math and then all the method names. And so I can get the absolute value. I can get the arc cosine. So I have lots of trigonometric functions that I have access to. If you need to take the seal or floor of the value, that's completely possible. So again, I had like 1.7, right? Or since it's a seal, 1.1. Anything with a fractional number would go up, and that's the opposite of floor, right? Anything that has a fractional just truncates that. Of course, another way to truncate that is just to convert into an integer. You can always convert into an integer. I believe, let me see. I'm not getting my languages mixed up. Yeah, I'm pretty sure that that's right. Yeah, okay, you can always truncate by just doing squiggle, squiggle too. So that's just an operator that does the same thing that math.floor would do. Okay, let's see here. Anything interesting? So I think the one big interesting thing I kind of want to show here, yeah, we have the ability to do power, max and min. I think I showed max and min before, so that shouldn't be a surprise, because with math.max, I can give a sequence of values and it'll give me whatever the max is. Same with min. Showed that one on the data structures one for destructuring. This is what I want to show, though, math.random, in just a moment. Is there anything else interesting? Anyway, so the point is, if you're looking to do relatively sophisticated mathematical computations, the same tools available to you for Java, built right into JavaScript, and it comes imported from the get-go. So you just call math dot whatever function you might need, and you can find the API right on MDN and make those calls out. So the one thing I do want to do is, and so this is true for Java as well. Let me bring this over here. So Java has a random class, but when I teach Java in 1583, I usually avoid the random class in Java as I prefer to use the math.random class, which is available there, because it's more akin to the way that random values work in JavaScript as they work in C++ as well. Python, I think, has a random module that you can easily use that's pretty powerful. That's more akin to what Java does. So if I do math.random, I am going to get a random number between 0 to 1. And so each time I invoke that, I can get a random number. Okay, let's clear that. Okay, so if I want to, let's say, model a 6-sided die, what do I have to do to this random value to model it to give me a behavior that's more dice-like? In particular, a 6-sided die, D6-like. Oh, yeah, okay. So the first thing I would want to do is, where did that go? First thing I would want to do here is, yep, and then do the floor. That's absolutely right. Okay, so just making sure everyone's very comfortable. So the first thing I do is I have to scale it up. So whenever we use a random number and it's essentially normalized between 0 to 1, you have a scalar factor and then a shifting value. So our scaling factor would be 6 because we want 6 different permutations. We want 6 different possibilities. So the scaling factor scales your random number between 0 to 1 to the number of different possibilities that you, or outcomes you want to have. So in this instance, there's 6 possible outcomes, which means that if I do this, okay, right, so lots of zeros, but all of a sudden I got a 5, right? And so yeah, perfect. So this will give me a number between 0 to 5, right? Because I can never get to 1. So it's between 0 to 1, but not inclusive of 1. So I can only ever get to like 5.9999999, whatever, right? Like never actual to 6. So if I truncate the number, it'll give me something from 0 to 5. So let's truncate that. I just showed that I can truncate using the, here we go, the tildes, double tilde truncate. So here, 1, 4, 1, 0, 4. And then if I want to actually shift the value of my outcomes onto a particular set of values, I just use a plus sign after I derived a random value. So if I shift by 1, I'm shifting the entire space. So my 0 would become a 1, my 1 would become a 2, my 2 would become a 3, my 3 would become a 4, my 4 would become a 5, my 5 would become a 6. That would give me a D6-like behavior. So just one thing that I wanted to highlight before we move away from the math class is that if you want to use random numbers, and of course you will eventually want to use random numbers if you want to have something that's kind of non-deterministic, just to recall how you can effectively use those by applying a scaling and shifting factor, and to always go ahead and try to truncate into an integer so that you get discrete numbers. However, only truncate after you applied your multiplier. If you truncate just the math.random, you'll always end up with a 0. I'm having problems getting a tilde, right? Because then you truncate the fractional number. Like this would be like the Sony approach of implementing a random number. For those of you who are familiar with the GeoHots hack that happened to the PS3. Okay. So the next built-in object I kind of want to move into that's worth knowing in JavaScript is the data object. So the data object, again, you can get all the actual calls right on MDN's, the Mozilla Developer Network's webpage. But the ones that I use that I find to be quite useful is the date.now one. So I don't know, has anyone used like the system.now from Java to be able to track the passage of time to try to evaluate for doing like time-based processing, temporal? Okay, perfect. Yeah, so the same way that you would have a system.now measure in Java, you have date.now, right? And again, it's going to return the numeric value at the current time, the number of milliseconds that's elapsed since January 1st, 1970. And so the nice thing about this is, so if I were to save that into a variable, let's call it start. Perfect. And now if I save another one, let's call it now. Here we go. And if I was to compare start now versus start, right, the difference is the number of milliseconds that have occurred between those two invocations. So for instance, if you wanted to have a, okay, let's do start now. So if you wanted to do like a while loop, so while start now minus start is greater than, let's say you wanted to do 5 seconds, then you do 5,000 milliseconds. And then if you were to do something like this, let's actually do start here is equal to date.now. And let's do okay. Then let's do something else. Let's do while it's less than 5,000, so that we'll keep processing this. Perfect. And let's do a console log. Do I want to do a console log? Yeah, sure. Let's console log what the value start is. Yeah. And then let's update our loop control variable. So let's make start equal to no. Okay. And okay, so that's an example of how I can ensure that a block of code only runs for 5 seconds. And then it's done. And then I could do the opposite. I can make sure that some amount of time has elapsed before implementing some kind of feature. So I don't remember if I use that in the platformer or not, honestly. But if I did, I want to explain the logic for that. So this is just something that's good and worth having. Now, there's other things you can do with date as well. So if I just ask for the date object, this window freeze. Oh, it did. I'll just my panel browser froze. Okay, perfect. We'll just make a new browser. This one. New window. Okay. Live coding sometimes. It's for the system. It's taxed. Oh, it's not what I wanted. Okay, let's go back here. Okay. Oh yeah, and so the next thing I want to show before we move on is date. So we have the ability to go ahead and at any time that we go ahead and construct a new data object, the default parameters for the data object are to go ahead and just give a time that is today, at this month, at this day, at this year, at this hour, at this minute, at these seconds, given this time zone. And so you can, of course, implement dates using a variety of parameters here, right? So for instance, we could do a new date, and let's see what happens if we just pass in one parameter. Okay, so if we do one parameter, notice it's giving us this date, December. Okay, let's see. Way in the future. Okay, so what do you think this single number is? If I just pass in the single digit, well, that's going to be that epoch timestamp. So let's see here. So if I do this. So effectively what that is that is the number of milliseconds. That's what's known as an epoch time. So if I want to convert between the number that I initially have from date.now to be able to track measures of time and then convert that back into a date, I could simply just go ahead and do that. I could just send that that value back into a date constructor, and date will construct that back into a date instance that is human readable and not just a big number. But we could do more things than that. So besides the epoch time, we can give like the year and then a month. Let's see here. And so here, if I just do two parameters, it'll treat the first as a year and then the second as the December 1995. Yeah, that's correct. December 31st. And, oh, yeah, I did the second parameter. And strangely enough, I don't know why I'm getting, I guess January is 0. Oh, Lord. Okay, well, yeah, that's so that important thing to know about the parameters for date is that it's indexes at 0 first. Okay. And then let's see here. Other than that, I think the other thing that's really worth learning that's built into JavaScript that we haven't covered before is the Json object. And so have we talked about what a JSON is yet? Has anyone heard of the term JSON? Because we'll be using JSONs later on in the semester pretty routinely. Yeah, so all a JSON is it's how we will serialize our JavaScript objects. Yeah, JSONs. So JSON is another way of being able to serialize data, much like markup is. And typically, you'll see ways to serialize that parallel markup versus JSON representation. So JSON actually stands for JavaScript Object Notation. So it's just a way of denoting objects in text files. One nice thing about JSON, though, is it's incredibly human readable. And for that reason, it's been a very attractive way of serializing our not only our JavaScript code, but code bases from other programming languages. So it's very common for other languages to have JSON files, whether it be C or C++ or Python. And one thing that it typically gets compared for, again, JSON's super popular for, say, for instance, setting up configuration information to initially launch an application. So let me see, did they give an example of Okay, they don't necessarily give an example of JSON versus XML, but I think when I have my slides for serialization, I'll just quickly cover over that again. But there's two methods that are worth knowing inside of the JSON module. And so this is how we can serialize our code. So if we ever want to send it to local storage, we can use this. So suppose that I had, okay, so I have JSON dot, and I can actually take any piece of data and I can stringify it. So stringify it is essentially what you learned how to do in Java 2 in terms of serializing your Java code. Now, when you serialize your Java code so that you can store those instances of objects and recall them for later use after you relaunch your application, you couldn't really read serialized Java. You can read JSON. It looks just like a JavaScript object, but as text, honestly. Okay, so imagine, let me create object first. So let's say I have this object that I'll call foo. Let's set, actually, let me clear my terminals. I don't have all this nonsense on there. Okay, so let's say I have this object foo. And I'm going to just use a object literal notation here. And let's say that foo has a name. Let's say that foo's name is R. Oh, look, if I'm doing literal notation, it's not necessarily that I'm okay. Okay, if I'm, since this isn't JavaScript. Okay, so foo has a name of bar. Let's say foo has an age of, I don't know, 300. And let's say that foo has a, I don't know, color green. And let's say that foo has, let's say, has a reverse. I don't even know what this is anymore, but I want to be able to give that like a true value. Okay, so let's see, I have a number in there. I have some attributes. That looks fine. Okay, so suppose that I want to be able to save this data, serialize it, so that I can recall it if I relaunch this application. Then what I can do here is I can go and I can say, hey, JSON, can you stringify some JavaScript data for me? I want you to stringify foo. And so there we go. The result of me telling JSON to stringify data value in JavaScript will be to convert it into a JavaScript object notation, which is a string representation of my object. Now, okay, let's do another one. Okay, let's do spam. Okay, so we'll get some spam and we'll put some, let's see, and there. Okay, so here I have an array. And again, this is a reference data type. So it's a little bit harder to serialize reference data types over primitive data types. So I could say, hey, JSON, can you stringify my spam? And there we go. We have a string representation of my array. Now, just out of curiosity, what if I console.log? What if I two-strung that? So let me do this. Spam dot the two-string method. So notice if I two-string it, I don't actually get a string representation of, I don't get a JSON, I don't get the implication that it is an array, right? I just get a comma separated list of those items with the built-in two-string method on array. So JSON.stringify actually captures the context of reference data types and allows me to store it so that when I recall it, I'm like, oh, I can reinitialize that as a array structure that contains this data. Or I can go ahead and reinitialize this object foo such that it's an object in my software again. So this idea of data persistence and being able to store data and recall it for some future execution is hugely important with serialization, and that's what the JSON class is going to provide to us. And super simple, you just pass your data in with stringify. Now, there is one caveat. I don't know if I showed what happens if I do string here. Yeah, So this is the big thing. If I simply try to toString my object, look at the default behavior of my objects. It just shows object object. If I serialized with this and tried to recall that for later use in my application, I would have lost all my data. I would have lost the concept of having a name or an age or color or a reverse attribute or property, right? So that is something. So JSON gives us what toString does not. First and foremost, it translates our data into a JavaScript object notation. But it's more than that. Okay, so let's go back here. And I said there's a caveat. I'll get back to that caveat. So let's call this foo string or foo JSON. Okay, so now I have this foo JSON, right? Perfect. And let me go back and do my my spam. Let me make a spam JSON too. Okay, perfect. Let's. Oh no. So, do I want to do that? Okay, so we have foo. We have foo JSON. Okay. So let's say I accidentally erased foo. Okay, so let's erase foo. Okay, so now I don't have foo. I lost foo, but I still have foo JSON, right? That still exists. What if I want to parse foo JSON so I can get foo back, so I can get it back into its original object state? Well, I could just say, hey JSON, I want to parse my foo JSON to this string representation, and bam, there it is. Look at that. That has been parsed into a JavaScript object. So that easily I can serialize and deserialize my JavaScript data. And I could do the same thing with that with spam. So I'm sure like it's way easier to serialize and deserialize JavaScript data than it is in Java, and it's way prettier to be able to read it as well. So big fan of the serialization. And same thing here with the with being able to do the same thing with array. Okay, so why does this matter? Well, one of the things inside of our client side is we actually have local storage available. So just to give you an idea why this is important, there's this thing called local storage, which I can't get access from about :blank. So let's just go to some other website. Okay, let's go. Not there. Okay, I know. Let's open up. So yeah, you're not allowed to hold local storage on a internal page on Chrome. So we have to at least open up a. So let's go to desktop. Let's go to web dev. Let's go. Oh, I can show off what the next lab is going to kind of look like. Exploration. Okay, yeah. So this will be fun. I'll show it this off, and then I'll use this to show what local storage is. So, nope, that is not. Ah, there we go. Excellent. Okay, so this will give you a quick indicator of where we'll be going after we're done our throughout this week. So. Okay, so let me access my local storage. So local storage. Yeah, so now I have access to local storage, as you can see. Local storage is a built-in API right on the browser that allows you to maintain data in between visiting a web page. So let me prove this concept to you. Let's see here. We have the ability, we should be able to set. So, and we should be able to set with a key value pair. So let's get some data first. So let me get foo again. Let's say foo is name R, and there's an X attribute 0. There's a Y attribute that we'll call, I don't know, 23. And let's see. Okay, that's fine. Oops. Okay, so so the first thing I'm going to do is let's go ahead and serialize our foo. So let's do JSON.stringify and pass our foo into stringify. Okay. Double check that. And JSON, yeah, perfect. Okay, let's go ahead and clear this. Okay, so I can always access local storage. I should be able to set local storage, provide a name. Let's call this name foo. Now, and let's give it a value, foo.json. Okay, no. Okay, so now inside of local storage, it's essentially just a dictionary. So I should be able to set with a key value pair. Now, presumably, if I go into my local storage and I pass it in foo here, I can recall that. So the special thing about local storage, again, was a built-in thing. I did not create this. If I refresh my page, right, I just refreshed the entire JavaScript runtime environment. Now, one thing you might have already realize whenever you refresh the JavaScript runtime environment is any active data that was in memory gets wiped. It gets refreshed. So every time you refresh the page, anything that was computed or processed is lost. So if you want to recall a user's state, application state, between visits, there is a couple of different ways to do this. If it's a client-side only app, such that you can't inject data from a backend service, then you can store the original client state during the running of your application inside of local storage. And so local storage is preserved in between visits. So if I go to local storage and I access my foo, there it is, right? Even though I refresh the page, I can keep accessing that. And the great thing about this is I can then do JSON dot parse here and parse the state of that object. And so if I were to save the state, I would probably make one big object that represented all the critical data of my application, and I would store it into local storage that way. And on load up of my application, I can easily access that. So this is a really nice feature to be able to have, and it's one that you'll have to be using for the homework that's about to come up, which is going to be to design a client-side application. So yeah, after we're done talking about the document object model and how event listeners are done, and you're getting a little bit of experience with that with the lab already, then you'll be primed to start designing a front-end application that's designed to run inside the browser. And so one of the important features of that is being able to maintain the state between opening the application so that you can track the progress. And so that's how you'll be able to do that. Okay, is there any questions with any of these concepts? Okay, perfect. I guess, perfect. So before we move on, let me show you what we'll be building. Let me close this out. Okay, so we're going to do two different labs as it relates to the document object model. I'm going to release the first, and they all build into each other. So the first couple of labs are going to be stupid tiny. They'll be like 4 or 5 steps, and they'll be pretty primitive, but the idea is to show you the basic idea. You're going to be building a number guessing game using the document object to interface between the browser's viewport and your JavaScript runtime environment. And we're going to incrementally keep adding more and more interactivity to it. And then after that, we're going to build an object-oriented version of an application that also accesses the DOM and builds what's called a single page app. A single page app means that we're going to start migrating away from this concept that our user experience traverses between different HTML documents. So up to this time, when we did our interactive game and when we had designed our portfolio pages, the idea is that each state of our web experience, of our website, was detailed in different HTML documents. But the downside of implementing a web application or a website like that is that every time you load from one HTML document to a new HTML document, you lose all the data in the JavaScript runtime environment. There's no carryover, right? Like you can't migrate your data that you had processed in one HTML document to bring to another HTML document. Like the idea is that each HTML document maintains its own state. And so I think that this was a realization for some of you when you were working on your interactive game, where there was a motivation where you wanted to go ahead and you wanted to be able to save data, like say, for instance, like give the character a key in one scene and then be able to use that key in some future scene. But it was a stateless system, so you couldn't maintain a state. And so that is the motivation behind what is called an SPA, or a single page application. So since JavaScript has access to mutate the viewport, the browser viewport, through the document object model, since the HTML elements are essentially modeled in memory for the browser and available to us via JavaScript's DOM, or document object, then we can stay on one page and just reload or rewrite the HTML elements based off of what is going on in our JavaScript application. And so that's what's really is going to happen inside of this second lab. So you'll have the number guessing lab, which just essentially sets up some event listeners, which we'll talk about. Oh Lord, it's almost already 3, which we'll talk about next lecture. And then in the lab that is a companion lab following that, we'll see how we can build a JavaScript application that models different views of our website at any given time based off of user interaction. And this is going to be a precursor. We're essentially going to have a precursor to React. So this lab, you will effectively build like a mini version of React using pure JavaScript, and then we'll take a small investigation of React on the front end. And that'll conclude effectively, after those couple of lectures, that'll conclude our endeavor on the front end, and then we'll pivot to building web servers for the second half of this semester. So let's see. So an example of this is, let me see if I can't get my, so if I look here, this is index.html. Let me see if I can stretch it out enough so you can see. Okay, index.html, right? I'm going to hit the start button, and you're going to see it loads to another page, but I'm still at index.html, right? And so I could, okay, yeah, the dragon resides in the ruins outside of town. You must go to its lair and slay it. Where do you wish to go? I can go to the dungeon. Well, there's no dungeon. This lab is exclusively a shopping. It's quite a tease in the fact that it claims that there's a dragon in these ruins and that you can go to this dungeon, but really all you can do is shop. But you'll see that we have the life bar, so we have 2 different views here when we launch the game. We'll have like this background image and the data that's given to the user, and then we have information that can carry over between each of our views inside of our game. So if you really want to improve your interactive game, you could use this lab and start maintaining state and start doing really cool things like having an inventory. So here I have like 3 life. I have a 1 attack power, 1 defense power. I have 10 gold pieces. I have 0 keys, and I can go shopping. But let's go to the shop. So let's see here. If I go shopping, I can buy food for 1 gold. Okay. I can buy sword training for 10 gold. Okay. I can buy defense training for 5 gold, or I can leave. If I leave, look. And again, this is all happening on the same HTML page, right? I'm just re-rendering my in-browser elements. And we're going to talk about that. That's the entire point of what the DOM allows us to do. And so this is a good demo of what we're going to learn how to do, build a single page application. So let's go here. And so if I wanted to, let's say, buy food, when I click on this, another nice thing about being able to do this is, saw that? It updates on the fly. So as I interact and mutate my in-memory document objects, it actually causes the viewport to re-render, right? If I buy food, my money's going down. So each time I buy food, and notice as I don't have enough money to buy sword training or defense training, it starts disabling buttons. So I'll just buy, okay, let's alternatively and go into here. I can just buy the sword training and it does. And so here my attack power goes up, all this goes down, all my buttons are disabled. Or I can go into here and I can do, oh no, I didn't want to do sword training again. I wanted to do defense training. Okay, now all I can do is buy food. Okay, so, but yeah, so what you'll see here is how we can essentially effectively do this. And let's see here. Let's actually get to the source. Dev tools. And if you look at my my source code, that's all my source code, or my HTML at least. If you look at my HTML code, that's all it is. I have Bootstrap that I'm using for the styling. I have one script that's called game, and the rest of this is, oh, well, you'll see that. And so now let me leave. And notice how everything changes. So let me refresh. So you'll see that all the state of my DOM as I interact with the code base changed based off my JavaScript behaviors. I did not build this using React. So this is going to be a lab, but the trick is when you build this lab, this is going to be something that everyone's going to build. This is a demo of what one of it's the next lab in the sequence. So you're going to do a number guessing game, which is going to be a trivial game, and then you're going to have a more realistic game. So I wanted to give something simple so you could see concepts in isolation. And then I wanted to give something that was more real so you could see how this actually looks as it's applied. But I kept the scope very small in here. I didn't actually build out a full game, just a couple of first landing. I built the landing page, an intro page, and a shop page. And then I built in the shop page the ability to interact to actually mutate the state of what's happening in the application. But if I go to the implementation, for those of you who are familiar with React, I'll show you really quick at the game script. You'll see that it very much looks like something where React would be defined, where I'm able to go ahead and have these classes that have a render method that returns the state as depicted in JavaScript. And then all my different JavaScript behaviors that then tell each of my components to set state, which causes a re-render of the viewport. So yeah, all this is actually just done in pure JS. But it'll lead to concepts that motivate what we're going to do in React. And so, yeah, the idea here is that we're incrementally kind of adding complexity to the tools we're learning so that React won't be so overwhelming when we first take and investigate it. Excellent. Okay. So I can close. So let's see. Let me close out of that. Let me close out of this. And let me close out of this. And so let me see if I have, okay, so I'll post the first lab, the number guesser lab, later this evening, along with the first homework, or not the first homework, the first JavaScript homework, which is going to be, the first part of that is going to be to design what your client-side application is going to be. and it's going to be something that's really just designed to run exclusively in the browser. Oh, that's a good question. So as I said before, I'm going to take a very opinionated approach to what material I can cover, and there's only 15 weeks in a semester, so there's only so much time that we can cover things. And jQuery, which used to be the very backbone of front-end development, has really become a much smaller thing. In fact, in the most recent update to Bootstrap, you might have noticed they've actually removed all the jQuery dependencies. So I'm going to treat jQuery as something that's outside the scope of this class, since we will be able to modify our DOM using pure JavaScript and the document object that's given to us right in the browser. And so I can actually start talking about the DOM today. I see that I'm kind of hesitant because I have 10 minutes left, and I want to use the 10 minutes to talk, but it's going to really mess the recordings up now because I didn't leave myself a lot of time to get deep in here, and I'm fearful. Okay, I shouldn't base my lectures off of the video recordings, but I might recover some of these concepts in next week's lecture as well, so that it's all in one recording. Okay, so but all this is going to lead us to the document object model. So instead of jQuery, traditionally, before we had a feature-rich document object model, we were forced to use an external, and by we I mean web developers, were forced to use an external library called jQuery. And so jQuery would traditionally provide you the work of using JavaScript to update your HTML elements inside the browser. But in the last 5 or 6 years, there's been a lot of effort in improving the built-in tools and objects and libraries that are supported in the browser. And so jQuery has kind of been made, for the most part, irrelevant with how powerful the document object model has become. Okay, so let's see here. So we're going to talk about the DOM. So what is the DOM? Well, effectively, when a browser loads an HTML document, the contents are stored in memory as the document object model, right? And so the DOM is available from both the JavaScript runtime environment and from DevTools. I think we've seen this before. Like if I actually go, let me show you here. So if I go to my about.blank again, to prove this, if I load into my DevTools, we've seen that the in-memory, right? In memory, all of a sudden, I'm giving my HTML and a body here, and I can actually go to edit as HTML, and to prove that these are in memory and what's used in memory is affecting what's happening in the viewport, I can actually add in a heading element here. Right now, this isn't actually looking at any HTML document. That's the beautiful thing about :blank. But I can actually modify the in-memory representation. Okay, click out of that, and there I go. And as I modify the in-memory representation, the viewport of my browser updates as the state changes. And so that's principally the concept. The same thing that I did here inside the DevTools to mutate the what the elements are showing, I can do from my JavaScript console, from the JavaScript runtime environment, from the interpreter. Okay, so changes to the DOM causes the browser's viewport to redraw, and the HTML DOM is modeled is constructed as a tree of objects. So each element inside of the document can be represented as an object itself. So I could have like a head object, I could have a body object, I could have a paragraph object, which is a member of the body object, I could have a title object, which is going to be like an HTML element, right? But it will represent the title, which would be a member of my HTML head object. So the document object model allows for us to finally get interactive HTML. So JavaScript can control essentially the view, and JavaScript can control the controllers. So in Java 2, you probably talked about the MVC pattern, the model view controller. And so the advantages that the DOM has allows for us to do is to programmatically be able to redefine and update what's happening inside of our view, so we can change, remove, or add any or all HTML elements and the attributes to those HTML elements, or we can change, remove, or add any CSS styling. And then in terms of being able to set up our controllers, we can have JavaScript React. Let me make sure this is the problem with doing that. It looks like I'm talking about React. I can have JavaScript react to all existing HTML events, or I can even have JavaScript create new HTML events. So a browser is an event-driven software application. So all interactions between the user and our application are going to happen via triggering events, handling events, listening for events. We'll talk more about that when I hit my event slides. Okay, so the HTML DOM is a standard object model and defines the interface for our HTML. So things that it defines are like the fact that all HTML elements are modeled as JavaScript objects, and that the properties, it defines what all the properties of our HTML elements are, so that we have access to them inside of our JavaScript runtime environment. We kind of seen this slightly inside the most recent lab with the platformer, where we can create a new image attribute and then assign to that image attribute an image object, which represented an HTML element. And then we could assign to that HTML element object a source, a SRC attribute, which corresponds with what the HTML source attribute would be. So properties in JavaScript represent the attributes in our HTML elements. And so our DOM will go ahead and define all the methods that allows us to access the HTML elements, and be able to also define means for us to set up our own events, so that we can interact with the user, we can interact with those HTML events at certain specified on specified callbacks. So when something occurs, we can respond to it. So we can have like a cause effect relationship defined in our application. Okay, anyway, in other words, the HTML DOM is a standard for how to get, change, add, or delete HTML elements. And so we can break our document object down into methods and properties, just like any other JavaScript object. The methods will define our actions that we can perform on HTML elements, and the properties are values that we can set or change. Okay, let's see here. So the HTML the document object. Oops. A little laggy. The document object is the owner of all the objects in our web document, though. So the document object represents our web page. To access any element in an HTML page, we start from the document object, and the document object is automatically imported into every browser JavaScript runtime environment via the window object, which is the global object. So whenever we start, if you might recall, whenever we start our browser, and I don't know why I keep closing my about : blank. Okay, whenever I start up and pivot to a web page, the first thing that gets imported into my console in my JavaScript interpreter, if I type in this keyword, as you might recall, points to the object I'm currently within. So I am never not within an object in my JavaScript runtime environment within the browser, because when I initially launch, I am set inside the Windows object, the window object, right? And the window object has all this stuff. In fact, oh my, I don't know why my computer's giving me such issues. Okay. I'm trying to unpack to show everything my window object has. But okay, there we go. So everything that I can do by default, all the standard library stuff, is part of this window object. So whenever you have a built-in function and you're not calling it on the scope of any other class, and that means by default is actually a function that is implicitly a part of this window object. So when this window object initially loads, it loads for us the document object, which will be a representation of whatever the current HTML document is for the web page that you're currently viewing. Come on, move to the next slide. Okay. Am I laggy right now? Because my computer is lagging out something fierce right now. Okay. Okay, good. Okay, so the next thing I want to show is, so to give you an idea, so if I just type in document, that's what I'm referring to. That's the document object model. And if I unpack just the document there, you'll see it contains the HTML elements. And then if I go to document dot, and then I could do all sorts of things. So the document object has all these different properties and methods built into it. So over the course of these of this lecture and tomorrow's lecture, we will finish going through this document object. But to give you an illustration, if I just go to, say, for instance, the document location, you'll see that that's a property that tells me where I'm currently at. So look, it shows that the href, the hyperreference for this current document, is about :blank. And it shows me what protocol I'm in. I'm in about protocol. And it shows me who the host is and where the origin is for this. So I can look up all this information, URL addressing this document right here. I can access that. I have to figure out. Nope, that's not what I want at all. Okay, so let's go to document dot location dot href, and let's say that I actually let's change that to www.google.com. Fail to set the href on a property. It's not a, oh, I need to give it a protocol, HTTP. And there you go. Notice when I reset the location attribute href right in my document object, it affected where I was in my viewport. All of a sudden, the URL google.com loaded up. Okay, so I'm kind of done fighting with this lag for today. I'm going to have to update my system, I think, and let let Apple resolve some of these lag issues I'm having. But we're going to pick back up with the document object. We'll finish off the document object next lecture, and hopefully we can also finish the event listener for next lecture as well. If not, we'll have completed all these by the beginning of next lecture. So is there any questions for today? Well, if not, then keep your eyes posted on Moodle. I'm going to be posting the new lab for today, which will be the number guessing game, and I'll post the instructions for the new homework today as well, which is going to be to start designing your own front-end JavaScript application. So we've covered enough JavaScript now that you should be able to start considering the designs of something that is novelly interesting.
I have a question real quick.
Oh, sure.
I just noticed, like, earlier I was doing the homework, not the homework, like the lab 4, and I ran into an issue when I was completing it. For part, I think either 1 or 2, when I was typing in the code for the console, it was giving me like a bunch of errors.
And that was the you said that was the so from some of the debugging that I helped with other students work with, the first thing I would suggest is make sure that all the methods that you're adding into your source code file are defined inside the class scope. So, because I know that has happened before. So whenever like I showed new source code in each of those window blocks, just make sure that the methods are just like in Java code. You would define all your methods inside class scope. This implementation is going to follow the same thing. So I don't know if that's what you were doing or not, but I would just double check to make sure that that's the case. Do you recall what the error was in particular?
It was like several errors. Like it was saying that like when I had like, it was saying that I had like a syntax error from like view.js when I double checked it and there was no specific error. Like that error that it says that there is I couldn't find it. And then it says that the background.png doesn't exist. And then when I did like view.picture for both spaceman and background, it said that it was just an uncaught reference error.
Well, I would just make sure that your file pathing is all correct for the things where it can't find the image. And here, actually, I can actually load into. So that's lab 4. Lots of my examples. It's platformer. I guess this is it here. So at least for the first one, let me show you. So at least for the first step, when you go to define the view, I'll give an example of what you should anticipate it should actually look like. And here, yeah, you can see I have my class view, and that all the methods that construct on that picture method should be inside the scope of view. And that's, my instance variables are declared as the first thing inside of the scope of my class, followed by the constructor, followed by the picture. And then finally, I'll go ahead and just create a global variable so that I can test it out.
Okay, I'll see if I can figure it out.
Okay, if you still have problems, just send me a message on Discord, along with whatever the error is.
Okay.
I also noticed that the files that I downloaded from Moodle didn't really match up with what the lab contained.
That's what I heard. Let me see. Let me download those files.
Because
really quick.
the
I've been having
files,
some
I think,
issues too.
one of like I don't think that there's like the pictures. I don't think that there's like, they have several background pictures, but none of them are named like background.png, and I think that's what we need for like this section. I don't know, like one is a picture of a sky, one is picture of something else. The background.png that's right there with the bricks, that's not in the folder.
Oh, interesting. So let's see here.
Yeah, and I just saw in the chat the starter files had the completed lab.
Oh Lord, yeah. I included the completed lab in the starter files.
Right, so I just ended up deleting all of them, and I'm trying to, I guess, wing it based off of what the lab's telling me to do.
Oh, excellent. Okay, I'll update. Okay, I'll update the. Let me actually do that right now. Let me stop the recording though. Here.